Determine the equation of a line for which the p values and the alpha values are given to us. Okay, now p means the perpendicular distance of a straight line from the origin, and alpha is the angle that this perpendicular line makes with the positive direction of x-axis. That in that case, what we have is the normal form of a line. The normal form. The normal form is given by x times cosine of that angle alpha added to y times sine of that angle alpha, and that is going to be equals to p. So this is going to be the equation of the straight line. So we'll use this. Let's begin with the first part of the problem. So here in the first one, we have the p value equals to 5 and alpha equals to 60 degree. That's quite straightforward. We have x times cosine of angle 60 degrees added to y times sine of the angle 60 degrees. That is going to be equals to 5. Now, what is the value cosine of 60 degree? That is simply 1/2. Added to y times, so we have y times sine 60 degrees, so that is going to be square root of 3/2 equals to 5. We're going to further simplify by multiplying throughout with 2, and that is going to give us x added to square root of 3y equals to 10. So this is the required equation. That is the required equation for the first one. Okay. So the first part of the problem is done. We'll go to the next one where p value equals to 4 and alpha equals to 150 degrees. So if when we use the normal form, the equation is going to become x times cosine of alpha, alpha is 150 degrees, added to y times sine of the angle 150 degrees, and this is going to be equals to the perpendicular distance 4. Now, our next task will be to obtain the value cosine of 150 degrees and sine 150 degrees. So let's do that. The cosine of 150 degrees, this can be also expressed as cosine of the angle 180 degrees minus 30 degrees. But there's a certain advantage to writing in this fashion. Cosine of 180 degree minus some angle theta, this is simply negative cosine of theta, or you can say negative cosine of 30 degrees. We're getting the negative sign here. That's because we are in the second quadrant. 180 minus 30, which is 150, it lies in the second quadrant where the cosine function is negative. So in other words, we're saying that cosine of 150 degrees, this is the same as negative cosine of 30 degrees. We know cosine of 30, that's square root of 3/2. We have obtained the value of cosine of 150. Let's now try to find out the value of sine 150 degrees. Now sine 150 degrees, what we'll do, we're going to rewrite 150 degrees. We can either take 180 degree minus 30 degree, or we can also express it as 90 degrees added to 60 degrees. So that is going to give us sine 90 plus some angle theta, that gives us cosine of that angle theta. Now, what? We are working with a sine function. We know that we are working with a sine function, and we are also in the second quadrant. In the second quadrant, sine is positive. Don't get confused with this cosine value that we're getting. The value of sine, this is going to be positive. So this is going to be cosine of 60 degree, which is 1/2. So in other words, we are saying that sine of 150 degrees, this is also going to be the same as 1/2. Let's use this value. We have x multiplied to negative square root of 3/2 added to y multiplied to 1/2. So this is going to be equals to 4. We can multiply throughout with negative 2 such that we get square root of 3 times x minus y equals to negative 8. So this is going to be this square root of 3x minus y equals to negative 8. This is the required equation with the condition that p value, that's 4 units, and alpha equals to 150 degrees. Now let's go to the third problem. Now we have the p value equals to 8 and alpha equals to 225 degrees, which means the equation of the straight line is going to be x multiplied to cosine of 225 degrees added to y times sine of the angle 225 degrees equals to 8. Let's find out cosine of 225 degrees. This is going to be equals to cosine of, we have 180 degrees added to 45 degrees. So the sum, that's simply 225 degrees. The cosine of 180 plus 45 means we have cosine of 45 degrees, but 225 means we are in the third quadrant. So we're in the third quadrant. the tangent function is positive, everything else is negative. So we'll get negative cosine 45 degrees, or we can say negative 1 over square root of 2. That is going to be the value of cosine of 225 degrees. Next, we find out the value of sine 225 degrees. So we are going to get sine of the angle. We have 180 degrees added to 45 degrees. So that is going to give us sine 45 degrees. Here we are in the third quadrant, so that's going to be negative sine 45, or you can say negative 1 over square root of 2. We're saying that sine 225 degrees, so that's also going to be negative 1 over square root of 2. Let's substitute these values. So we have x times negative 1 over square root of 2 added to y multiplied to negative 1 over square root of 2 equals to 8. Or we can multiply throughout with square root of 2. Let's do it with negative square root of 2. So we get x plus y equals to negative 8 times square root of 2. And this is going to be the required equation. Thus, x plus y equals to negative 8 times square root of 2. That is the required equation of the straight line. Now let's move on to the fourth problem. So we have p equals to 8 and alpha equals to 300 degrees. Our equation is going to be x cosine of 300 degrees added to y sine of 300 degrees equals to 8. Let's find out the value of cosine of 300 degrees. So cosine of 300 degrees, so we can break down 300 degrees as 360 degrees minus 60 degrees. Now cosine of 360 minus some angle theta gives us cosine of that angle theta. And 300 degree clearly means we are in the fourth quadrant where the cosine function is always positive. Cosine of 160, that is equals to 1/2. So in other words, what we have obtained here is that cosine of 300 degree, that's equals to 1/2. So here we have x over 2. Next, let's try to find out the value of sine 300 degree. So sine 300 degree, that is going to be equals to sine 360 degrees minus 60 degrees. So sine 360 degree minus theta, that gives us sine theta. We should get sine of 60 degrees, but we are in the fourth quadrant, so we should have negative sine 60. In other words, what we get here is negative square root of 3 over 2, and this is going to be the value of sine 300 degrees. We'll substitute this into our equation, so we get negative square root of 3 over 2 whole multiplied to y, and that is going to be equals to 8. Let's multiply with 2. So we get x minus square root of 3y equals to 16, and we can say that thus x minus square root of 3y equals to 16. This is going to be the required equation of the straight line. Okay, now let's move on to the fifth problem. Number 5, we have p equals to 3 and alpha equals to the arc tangent of pi over 12. Okay, so our equation is going to become x times cosine of the angle alpha added to y times sine of the angle alpha equals to p. So p value, that's equals to 3. Let's try to find out cosine alpha and sine alpha, because here we have the value of alpha given by the inverse tangent or the arc tangent of 5 over 12. Okay, let us begin. So here we have alpha equals to tangent inverse of 5 over 12. Or what we can do, we can simply take the tangent function on both sides to get tangent of alpha equals to 5 over 12. Now let us consider a right angled triangle, and let this be the angle alpha. This is 90 degrees. Now we know that the tangent of any angle, this is simply going to be the ratio of the opposite to that of the adjacent side. Adjacent. Now what is the opposite? So that means the opposite corresponds to 5 and the adjacent corresponds to 12. Now we can use the Pythagoras theorem to immediately obtain the value of the hypotenuse, which must be equals to 13. Okay, so now we have all the three sides of the triangle. We can immediately obtain the value of sine alpha as well as cosine alpha. So sine alpha, that is given by the opposite. We have the opposite divided by the hypotenuse. So the opposite, that's 5. So we have 5 over 13. So this is going to be the value of sine alpha. What about cosine alpha? Cosine alpha is simply given by the adjacent over the hypotenuse. So adjacent, that's 12. So we have 12 over 13. Let's use this value. We have x multiplied to cosine alpha. We have obtained cosine alpha as 12 over 13 added to y times sine alpha. So sine alpha, we obtain it to be the value 5 over 13. This is going to be equals to 3. Multiplying throughout with 13, we get 12x added to 5y. This is going to be equals to 39. Thus 12x plus 5y equals to 39 is the required equation. This is the required equation of the straight line. Now let's move on to the final problem. So here we have the perpendicular distance equals to 2 units. Alpha is given as sine inverse of 1 over 3. Okay, so we need to find out x cosine of alpha plus y sine of alpha equals to p, and that's going to be the equation of the straight line. So here let's start with the given alpha value. So alpha is given as sine inverse of 1 over 3. Okay, so what we'll do, we're going to take the sine function of both sides, and that's going to give us sine of alpha equals to 1 over 3. So here we have successfully obtained the value of sine alpha. Now we can also obtain the value of cosine alpha, because cosine of alpha, that is simply given by square root of 1 minus sine square alpha. We're taking positive value here. So that is going to be equals to 1 over 1 minus 1 over 3 whole square. Solving this, we are going to get 8 over 9, or we can say 2 times square root of 2 divided by 3. That's cosine of alpha. Let's substitute this value here. So we have x times cosine alpha, that's 2 times square root of 2 divided by 3. Added to y times sine alpha. So sine alpha, that's 1 over 3. This is going to be equals to p, so that's 2. Multiplying throughout with 3, we get 2 times square root of 2 multiplied to x added to y equals to 6. Thus 2 times square root of 2x plus y equals to 6. This is the required equation. That is the required equation of the straight line.